Assalamualaikum, welcome to the part 3 video for chapter 6 gravimetric analysis. So in this video I will explain about the precipitation of precipitate. So what is the precipitation? So precipitation is the process when you adding the precipitation reagent into the analyte. So when the analyte react with the precipitation reagent, what happen? You get the precipitate. So the process will occur when the portion of dissolved chemical leave the solution to form a solid. So precipitation got many what we say is many type of precipitation. First we going to a granular precipitate. Granular precipitate is very desirable in gravimetric analysis because it presents a relatively small surface area. Okay, so when the small surface area, it will become the less liable to be contamination. So after that, it also be easier to be filter granular than gelatinous precipitate. So what is the gelatinous precipitate? So gelatinous precipitate is the precipitate like a gel or like a water. Okay, so when the structure of the precipitate is gelatinous, it's very hard to filter. Okay, so precipitate made up a large particle or crystal are desirable for gravimetric works because large particles are easy to be filtered and can minimize the contamination from impurities. The precipitate also should have a low solubility in the solution. So there are two types of precipitate, which is crystalline and colloidal suspension or colloid. So crystalline, by comparison, is the precipitate which the last size, which is more than 10 power of minus 4 centimeter, and by precipitation process, it will be settled spontaneously. And the precipitate by crystalline is easier to be filtered and purified. And for crystalline also have a low RSS, which is low relative supersaturation. So for RSS, I will explain in the next slide. Okay, so compared to the colloidal suspension or colloid, if the by character is a tiny with diameter, the diameter is between 10 power of minus 7 to 10 power of minus 4 centimeter, it will be not settle, not easy to be to get the precipitate, and not easy to be filtered because the size is very small and the RSS value is very high. So this is the explanation about the RSS. The RSS is the relative supersaturation or relative supersaturation, RS equal to Q minus S over S. So what is the Q? Q is the concentration of the solute at any instant, okay, which is the concentration of solute before the precipitation, and S is the solubility of the precipitate at equilibrium. And by this equation we got the conclusion. Okay, you need to know and you need to understand the conclusion. If the RS value is large, so the precipitate is colloid. If the RS value is small, the precipitate is crystalline. Okay, so what happens if the precipitate is colloidal or colloid? So if the precipitate is colloid, we can assume the nucleation is dominant and the small particle of precipitate produced. If the RS value is small and we assume the precipitate is a crystalline, so in the process to make the to produce the crystalline precipitate, the particle growth happen in the process and the large particle of precipitate produced. Next is the properties of the good precipitate. Okay, so what is the properties of the good precipitate? So precipitate that we need in the gravimetric analysis should be large. So they consist of large crystal that can be easily be filtered and free contaminant. So the product also sufficiently insoluble, so that the amount of analyte lost to refiltration and washing will be really low. And another properties of the good precipitate is stable. Stable means the precipitate is unreactive. If the precipitate is reactive, sometimes it will react with water and another constituent. Okay, so it will produce another product. So we need the precipitate that is very unreactive. So when the precipitate is unreactive, so it becomes more stable. And also the precipitate is non-competition. Okay, so the composition of the precipitate, we should know what is the structure, what is the formula of the precipitate, and how to get that precipitate. Sometimes we need to dry, or sometimes we need to ignite, okay, that precipitate before we wait. Next is how to form the last particle or precipitate. The last particle in granular form can be achieved by precipitate from a dilute solution. So at the setting reaction or the setting analysis, the analyte should be in a dilute solution. By adding the precipitating reagent slowly and stir effectively. So we are not suggest to put the reagent very fast, and also not allowed to stir very vigorously, or we stir it very fast, okay, because we need to the reaction occur at the very effective condition. And the precipitate is from the hot solution, okay, and also the precipitate at low pH. And how to maintain the pH, how to maintain the condition of temperature. We need to lowering the temperature slowly, okay. And the last one is by adding the organic solvent that can mix with water, okay. Sometimes we don't need the water entrapped into the precipitate. This is the same example that I already explained at the last slide. This is the precipitation process, how precipitate is formed. So when we add in the analyte and the precipitation reagent, the solution becomes supersaturation. After the supersaturation condition, the precipitate is begin to be produced. Okay, so any precipitate, we first the condition must be supersaturation before the precipitate produced. So precipitating reagent or precipitant, we choose for the precipitating reagent was chosen for the ability to be selective and form high insoluble precipitate. Okay, and this precipitate also is easier to be filtered and reproducible stoichiometry, which is we know the stoichiometry of the reactant and the product, okay, and we know the reaction. What is the reaction between the precipitation reagent and also the analyte to become a product? So there are two types of precipitant, which is the organic precipitant and inorganic precipitant. So this is the comparison between the inorganic precipitant and organic precipitant. Okay, so for inorganic precipitant, it forms the slightly solute salt. Okay, so they can produce salt. Okay, compared to the organic precipitate, it's useful to precipitate metal. Okay, and most of the precipitate for inorganic precipitate is not selective, and for organic precipitate is very selective. Okay, and for example, for inorganic precipitate is a silver nitrate, okay, and used to precipitate the halide ion, for example, chloride. And for organic precipitate, there are some advantages compared to inorganic precipitate. For organic precipitate, the advantages is from the chelate compound with a cation, which are very insoluble in water. So the metal ion may be quantitatively precipitate, and also it has a large molecule weight, okay, a large molecular weight for organic precipitate. And the last one is the advantages of organic precipitate. The precipitate obtained are usually bulky and coarse to thus easily to handle. Okay. This is the common inorganic precipitate. Okay, you can see, you can read it by your own. This is another common inorganic precipitate. And this is the table, which is what is the analyte in the solute. What is the analyte set table for the precipitate that we produce. Okay, because in gravimetric analysis, you need to know what types of analyte in the solution, what types of what structure of your gravimetric precipitation reagent, and what formula of your product. Okay, because you need to measure the mole or the stoichiometry for another for calculation for gravimetric analysis. And this is the another organic precipitant. For example, is 8-hydroquinoline. So 8-hydroquinoline oxide used to precipitate a large number of elements or precipitating reagent. So precipitation occurs selective and controlled by pH. For example, in pH 4 condition, aluminum ion can be easily precipitated at pH 4, and magnesium ion at concentration of anion form of oxide is too low at pH 4 to precipitate magnesium ion. So higher pH is required to show the ionization step and precipitate of the magnesium. If pH is too high, the magnesium hydroxide will precipitate, causing the interference. So in this situation, we need to maintain, make sure the pH condition should be 4. If the pH is higher, we need another precipitate. So another precipitate, another compound, will become the interference or will be impurities to the main product that we need. So this is the same explanation. You can read it by your own. And this is the last one, which is the mechanism of precipitation. So the mechanism of precipitation is simple. It's starting with the nucleation. So if the process of nucleation occur as spontaneous, it will become the colloid particle. Okay, and how to avoid this condition? We need to induce. Okay, so what is induce? So induce is we put another requirement. We put another item, for example, seed particle. Okay, so this induce also we can put another dust or crystal or glass fragment. So what happens when we induce the nucleation? So the nucleation, the particle, the precipitate produced will grow. So it becomes the particle growth happen in this situation on this condition. So the particle growth will produce the precipitate of the type of crystal. So the spontaneous, if you can see the explanation at the below of the picture, the spontaneous nucleation will occur and in home. So induced nucleation require a seed particle to get the thing started. Okay, so by spontaneous, it will produce a very slow reaction and will produce a colloidal precipitate. And by induced, sometimes we need the particle growth to produce the precipitate, which is the type of crystal or a big particle. So the nucleation is the individual ion, atom, molecule collision to form a nuclei. A nuclei with a small particle come together to form a colloid particle. So we need to avoid colloid particle. So we need to activate. So or to induce by adding the dust particle, the scratch on the vessel surface, and also by using seed crystal. So by using this method, we will make the small particle, the nucleation, become the colloid particle, and the particle will be growth into the big particle or the crystal particle. So the nucleation increase, it leads to more number of small size colloid form of crystal, so it leads to absorb the impurities. So that's all for this video. Thank you.